Hello and welcome back to Calculus 1. This is exam 1 review because in your infinite wisdom you picked to have the test on next Thursday, right? So there you go. Now we have to talk about this. Exam is on chapter 2, but some of the review concepts from pre-calculus that we really need so that you can survive any and all calculus courses are going to be in the chapter 1 review. Also in the chapter 1, if you take the pre-calculus book, which is free for you to reference in the library or the tutoring center or my office. So, exam 1 is out of 100 points or 107, right? You did the quizzes. And it's on chapter 2.2 to 2.7, where 2.7 is just that definition, right? We don't have problems. We're not calculating problems from 2.7. You just have to memorize that definition for the limit, epsilon delta, and those two accompanying pictures, what they mean, right? Now, in addition to this, we have those pre-calculus concepts that you have to have. So, we start from, I'm just going to put chapter 2 plus pre-calc. How about that? That's much better here, and now let's go and do the detailed stuff. Number 1, definition of the function. I told you that this question is definitely on the test. You either state it exactly as it is or you don't, right? So definition of a function, and you have it somewhere in the first day. I wrote it somewhere. If you don't have it, I can write it later again. It's fine. Number 2, graphing functions by hand with shifts and flips. Now I'm going to put 1.6 and I'll explain 1.6. We don't have 1.6 in our textbook. This 1.6 is for pre-calculus textbook. This 1.6, okay? 3, function composition. This is 1.7 in pre-calculus book. And inverse functions. That's 1.8. So definition of the function. So this is your pre-calc stuff. It's all chapter 1 in your pre-calculus book. We are using good effort. We have the chili pepper by Blitzer, right? The book, it doesn't matter which edition you pick up. Edition 2, 3, 4, 5, 6, whatever, how far they went. All of those books are available in these locations. So you can go and review some of the stuff that you might have missed. Definition of a function. Calculus is all about limit of a function, derivative of a function, integral of a function. If you don't have a function, you can't do calculus. You have to be able to spot if the function is, if the expression is a function or not. So that's that. Graphing functions by hand. Remember, no graphing calculator on the test. That's the rule of the school. So, rule of RVCC. So you have to be able to graph the functions. You know that if you have 1 over x, that's the right basic, and if you have 1 over x minus 3, then you go 3 units to the right and then you draw the function, right? So these types of basic shifts, and then the minus sign flips the function and all of that good stuff. So you have to be able to graph. You need to know the quadratic, the linear, the cubic, the square roots, the e to the x, the ln x. So that's that. Function composition, well, this one is easy because you are still doing it forward. So I give you f of x, I give you g of x, and I ask you what's f of g and what's g of f. right? So that's 1.7. And inverse functions finally. So you can do trig with inverse trig, exponential with logarithmic, x squared with square root, and then linear with itself, right? The inverse of a linear function is a linear function. So that's important, and some of the formulas going down the line will touch on this. So we need to know. Now, so that's pre-calc. Draw the line. Number 5, find limit with graph or chart. That is 2.2. 6. Find limits using algebra. That's 2.3. Number 7. We have infinite limits. Plus vertical asymptote, 2.4. Limits at infinity. Plus horizontal asymptote, 2.5. Number 9, continuity. And 10, definition of the limit. Plus 2 pictures. I just realized I can just go one problem per thing, right? And be done. Watch for questions which say state the formula, state the definition, state the, right? Those are freebie questions. If the question says write a paragraph explaining limit exists or does not exist, well, you have 2 options in that case. If the paragraph is that vague, you can either base it on your theorem that the left limit and right limit have to be the same, and if they're the same, you have the limit, and if you don't have the limit, then if they're different, then you have no limit. That's one way. You write it in a paragraph and you're done, and you write the formula which we have when limit x approaches a minus of f of x is equal to the limit x approaches a plus of f of x, right, is equal to L, then the overall limit is equal to L. Otherwise, does not exist. That's the one way to answer a question like that. Or write a paragraph, it's the same question. You can use the 2 pictures from 2.7, right? And you say those epsilons, right? As you squeeze delta epsilon squeeze into a point and we have a limit, or as you squeeze deltas epsilon go apart, right? Epsilon is supposed to be an extremely small number. Well, when you squeeze on those deltas, the epsilons go infinitely apart. And that's not a very small number. That's complete opposite, so limit doesn't exist. So that question can be answered in 2 ways. Obviously, state definition of a function, that's only one way. State definition of a limit, that's epsilon delta, only one way. But if it's question on a procedure, right? On a procedure on how to find the limit, you can do all of those things. What are the rules for continuity, right? At the point. F of a has to exist, limit of f of x has to exist, they have to be the same. The list is right, so that could be a question. So, your questions will not only be with x's and y's, but they will also be the basic understanding of these things, because many of you would like to be successful, right? Well, I told you this 2 or 3 times already. Calculus cannot be done as algebra monkey sees, monkey do. All right? You have to understand theorems and definitions if you are to have a chance. The same theorem deals with x plus 3, x squared plus 3, or e to the 3x, or sine of 3x. All right? So it's the same theorem that applies to all of those, and all of those problems look miles apart from each other. All right? So it's very important that the question says state the formula for vertical asymptote. Hey, that's the limit, right? Limit x goes to c plus or minus, you put whatever, of f of x is equal to positive or negative infinity. Boom, vertical asymptote, done. That's defined in 2.4. I know, I did it. Right? So, what is the definition for the vertical asymptote? Clearly stated in red, right? So what kind of question other than state this could be a question? Well, I can say prove that x equals 3 is vertical asymptote. You crank that. Or prove that x equals 3 is not a vertical asymptote. You still do that. Because if you get a finite number, you know it's open circle. If you get infinity, it's an asymptote, right? So, whatever. So that's that. And, you know, most of the problems, well, we did in class everything, but as I said, most of the problems are on limits. Vast majority of the exam, and then some maybe 30-35% on pre-calc. So 1/3 of the grade for pre-calc, and then 2/3 maybe, something around there. I mean, I don't go on and measure these things, right? It's somewhere roughly in that area, and the pre-calc stuff is obviously important because you must know those basics of functions, otherwise the most important derivative techniques and things, you won't be able to do them at all if you don't know function composition and stuff like that. Chain rule is function composition, and that's the most important derivative technique that we have. Like 90% and more of your derivatives will be chain rule going through Calc 1, 2, and 3. So if you don't know function composition, well, guess what you can do? The most frequent derivative technique. That means 2 chapters are out, right? From Calc 1, it's gone. So, so that's on the test, and just, you know, watch your notation. Make sure you don't drop limits. You keep writing limit until you use it, just like in the previous lecture, right? If you take a look at my steps over here, every single one has a limit. There's a limit over here. Oh, come on. And again, and again, and again, and again. And I finally used it up. There's no limit over here. There's no limit in this step. So, it's not, oh, it's implied. It's not implied. It's implied only when you write it. And you keep writing that limit over and over and over until you get to use it, because when you are doing your PEMDAS problems in algebra, you keep copying everything that you are not using with their symbols until you get to use them. So don't discriminate against limit because it has numbers, letters, right? It's not a cute symbol like a plus or times. Limit is mathematical operator, and you get to copy it 50 times if you have 50 steps, and then finally 51st step is when you use the limit and you are not writing it anymore. Also, I asked you before, I'll ask you again, if you have a vertical asymptote at x equals to 3, that's a cool way to write it. That's the way to write it. Horizontal asymptote at y equals to 0. That's the good way to write it. If you write VA equals 3, I'm going to cross it out for -2. Because that's meaningless. Has no meaning. VA equals 3 has no meaning. This is the way you say vertical asymptote. You can spell at. That's fine, right? Or you can put the monkey, whatever. right? So these are the things. Do you have any questions, concerns, problems? There will be no 2.7 proofs on it. That's for the honors.
So we need to write down the definition of function. You need to write down the definition of the like after statement.
Yes, that's this.
How about the other definition? Do we have to state it, or do we just involve?
Well, no, if you know them. I mean, I just told you what are the most important ones, right? The left and right side for the limit, epsilon delta for the limit, definition of the function, and you have the continuity, 3 rules, and then global continuity is when it's continuous on each one point individually, and then you have those 2 big theorems for continuity where these functions are continuous, right? Where we list polynomials and all that, and then the second one, combinations of continuous functions are continuous. So it's a finite bag of maybe 10 of those, right? It's not that crazy. But you know, if you don't know them, obviously you can do problems. You can do problems because you know, if e to the x shows up or a sign shows up, you need to know that it's the same as if you have x squared. It's just that, you know, different type of function, and you just calculate within those limitations. That's that. If you are missing function definition, yes.
For like number 5 was responding in the graphical chart. Will we have to graph the limit that you give us?
Yes.
Okay.
Yes.
Oh, I thought that was like a separate. So that's.
See, yeah, I don't have to have a question there. I'm just I can ask, find the limit of e to the 2x minus 1, right? Or x plus 2. There we go. Minus 1 as x goes to 0, right? Graph. So what do? Okay, you say, okay, to the x goes like that. Minus 1, so now it goes like this, plus 2, shift to the left, so this is 1, so it has to go through negative 1, so there we go, and now I need this at x equals 0, so whatever it cuts, that's where the limit is, right? So these are the things that, this is a shift down, this is the shift to the left, and you utilize those shifts to create the graph. So these graphs, this is what I said, it's 1.6 in a chili pepper book, right, Blitzer. These books are available, they should be on my stream, 1.6 as well, on how to graph functions, if you have issue with that. We're going to have a lot of graphing in this class, and 0 calculator, right, for graphing. So the sooner you address those issues, the better. Because we are going to use these 3 sections heavily as we go through the class. So please look into these and do it. Definition of a function. Function is a rule which assigns to each x in the domain a unique y in the range. We underline rule, domain, range, and unique. So you either write this for 4 points, or you try to make up something for 0 points, right?
Can you upload this?
Yes. Yes.
On the test we have to underline?
No.
On the test Professor, we're gonna have like phase shifts of like sine and cosine.
No need.
Not really.
We should, but no need.
So we're not gonna have any,
I'm sorry?
we're not gonna have any like,
Trig?
yeah.
No, there's Calc 2 coming up. It's gonna make up for it. Like big time. We are going to have graphs of trig in the class, but yeah, there's no need to rush into things because the winter is coming. It's always coming. Until it passes, which is when you go to Calc 3. Then the winter is over. Unless you are completely incapable of dealing in 3D, then the winter continues, but not for many. Anything else? Well, I'll see you on Thursday. Yeah. Please don't. Please don't. That's the best thing to say.